and not too sleepy. So the idea of this session is just to talk a little bit about battery options in the data center, and specifically talk about lead acid versus lithium-ion and what might be appropriate and the way we might be making choices about which way we go forward. To discuss that, what I'm going to do is have each of the panelists sort of introduce themselves, say who they are, who they work for, and what their interest in this area is. So, in no particular order, Richard, if you could start us off, that'd be great.
Hi, everybody. My name is Richard Pimper. I'm the VP and CTO of Huawei. And as you know, we have the truck here. You can see our lithium-ion batteries. And we started working with lithium-ion batteries roughly 10 years ago because of the carrier. So we have experience, in my opinion. So I'm looking forward to a good discussion today.
Hi everybody, Paul Smethurst from Hillstone. We make load banks, so we don't sell batteries, we don't sell UPS, we don't sell generators, but the load banks have been used for testing the said products for the last 30 years. We actually started in my father's garage and we lived on Hillstone Close, and we've opened up recently in Dundalk as well, so we've got an Irish load bank company now based around here in Dublin as also. So all load banks and testing batteries is what my focus and passion has been.
Hi, good afternoon. My name's Phil Hardy. I work for Leoch Battery. We sit with one foot in both camp, lead acid and lithium. So I bring that topic, my thoughts on that topic for this discussion. Back to you, Mark.
Yeah, thanks, gents. The way I'm going to start off is basically by saying that we are clearly using lithium-ion in multiple sectors, electric vehicles, etc. So they are pretty commonplace, and they're an understood technology, or maybe understood. We'll probably explore that one a little bit, but we're not really seeing a huge amount of adoption in the data center sector yet. And Phil, maybe you can sort of start us off by explaining what level of adoption you're seeing in the data center sector, and maybe why there's a relatively slow adoption for the sector.
I think we have to be careful that lithium isn't the answer to everything. There are pros and cons for every product out there, and lead acid has been a leader in UPS and standby power application. And maybe Richard will be able to explain better about the UPS side, but obviously lithium. The development we've done with lithium is nominally 48 volts for the telecommunications market. For UPS, you need a higher voltage, which brings its own challenges on the BMS. But obviously, the BMS within the lithium battery gives you a lot more visibility and a lot more controllability of the battery. So there are benefits and features for lithium, and I think it's going to come into the data center space because there are options and savings for lithium. But as we all know, despite the fact that the data center being a relatively new market, it just takes a long time for everybody to change. Yeah. So it will take a little while, but I think the take-up is coming, and it's as more people enter into the space, there'll be greater development, and it will be much more positive.
Yeah, as you say, we're a technical sector, but we are fairly slow to adopt technology sometimes.
Yeah, yes, definitely.
And Paul, what about your perspective on that? You're seeing it as an objective observer. Slow take-up, concerns?
Well, I don't sell batteries and I don't sell UPS, I don't sell generators. So what I can do is I can go back and look at the history of batteries in terms of lead acid. And we've got new technology now in the thin plate pure lead, which if we're comparing that against lithium, and then the lithium is what type of lithium we are talking about, then we can, in the UPS terms, the UPS is only as good as the battery. Of course. So if you've got a cheap 5-year battery, which lasts for 2 to 3 years, that is going to give you lots of replacement against a 15-year design life lithium battery. But then my brain starts to think and say, the Plant A cell was 25-year design life because it's since 1902 we've seen 25 years of that battery. We know at 26 years it has a problem. It might be positive pillar corrosion, might be the growth on the bars, the case cracks. There's various reasons those batteries fail at 26 years if you're doing all the maintenance properly. You look at lead acid sealed products, it's maintenance free, or is it? Because it's not a sealed battery, it has a vent on it. It's not maintenance free, you have to do other types of maintenance. And the commodity of the battery on the UPS has been driven down to, the price has been driven down. So you're not comparing like for like, but if you consider the thin plate pure lead, then you've got something which has got advantages that you're paying for. On the lithium battery, it's a lot more expensive. Dare I say, more profit? Is it, is there a marketing, is there a sales angle to push in a more expensive products? But the one thing we've not done is had the 15-year life cycle go through. There's other things I can say about. I won't say everything I've got in my brain at one go because we'll run out of time.
Let's save something.
But there is questions, and the industry needs to be better at promoting both the technologies.
Yeah. And more understanding, I think. And Richard, as obvious, Huawei are a battery manufacturer. You're supplying lithium-ion batteries. How do you see the take-up, and are there any challenges that you see? And maybe we're talking about the different technologies that are available in lithium-ion. It's not one size; it's different chemistries.
Exactly. So I think first of all, when we're talking about data centers and different technology or batteries, everybody here is from data center sector. So the first point is the security. So we want to have secure or solution. Doesn't matter what kind of material we are using. The Huawei idea was that because of the carrier part, there are lots of innovation was in the last 10 years. We started producing 4 years ago the first lithium battery solution. The third phase is just starting next year. And we have relatively very good experience with them, selling a lot. And our approach is different in terms of what kind of lithium we are using. We are using the most secure one, which is the lithium phosphate in our terms of understanding. And of course, when I'm talking about security, it's we're always checking two things. One of the thermal runaway, and second one, the production of oxygen. So this type of lithium is the highest, 460, 465 degrees thermal runaway. And the second one, which is very important for us, if you see our solution, we are talking about modules and modular. UPS isn't also in batteries. So that's basically a very good raw material to have modules. And other one, but everybody said here, and Mark asked the floor load and the floor space. So this is also very important for retrofit projects and also the new projects. Everybody wants to have more and more and more white space and less for the technical room. And last but not least, which I think we little bit forget, in the new term on technology, the temperature inside the data center is higher than like 10 years ago. And for example, our batteries can work together with the UPSs with free air cooling only. We can go up to 35 degrees. Of course, this is not ideal, but in case 1 or 2 weeks is there, is not a big issue. So this is also saving cost. So just recap what I said. I think one thing is how much does it cost, and the second one, everybody checking 15 years TCO or 10 years TCO, doesn't matter what kind of solution they have, and we are calculating 15 years. And if you see the TCO, then it looks good, basically. Yeah.
Yeah, and I think also, to me, it seems like there's this real perceived risk of fire with the lithium-ion batteries. But I think one of the things that, when I started to look at this, was the realization that it's not simply about lithium-ion batteries catching fire. There are different chemistries, some of which are more prone to fire, and again, as you say, Richard, produce oxygen. Others don't at all, and actually the risk associated with that seems to be very, very, really quite low. And let's face it, lead acid does catch fire as well, Phil. I mean, so is this a perceived risk, or is it a real risk that with the concern over lithium-ion?
There is a lot of news and a lot of noise about the risk, but it is about the chemistry. The lithium phosphate battery seems to be the leader in the choice that people manufacture. I assume that you're using...
Exactly.
Yeah. So then the next step up for that is lithium titanate, but that's the cost is just taking that out of the park, really. So lithium phosphate is still very strong and stable chemistry. And that's what you've got to think about, is the chemistry that's being utilised. And as you said, the heat management of that chemistry, we can go up, the thermal runaway is above 400 degrees C. I can't imagine a lead-acid battery in that sort of temperatures, thermal runaway. So the heat management is much better for lithium phosphate. There are dangers with both, and it comes down to maintenance. You said a phrase which probably was the worst thing that the battery companies ever did, was talk about maintenance-free batteries. Right. They should have said it was maintenance reduced, or, it's not a fit and forget thing, whether it's lead acid or lithium. You don't just, let's take your car, for example. You don't just drive your car, you get it serviced, you check the tyres, or you should do, according to the highway code. You make regular checks. And by doing this, you will start, reducing the risks and the errors that come in. And at the end of the day, most of these errors are done by humans and the misuse of the product. That's not to say there is no risk with lithium. That's in the same way that you can't say there is no risk with lead acid, in the same way you can't say there's no risk with fuel cells. It's how you manage it. The beauty about lithium is it comes with its own watchkeeper, whatever you want to go, safeguard, which is the BMS. The BMS will control what you do to the battery, and it will make sure that you don't abuse it, and also it will record any damage that you do to the battery. So it's a step forward in technology. I don't think we should be. We should just be cautious and utilise it correctly. That's as with all things.
And I think you make a really good point about the monitoring and the management. That's obviously a significant factor. So I mean, from your perspective, Paul, the fact that the lithium-ion batteries tend to have that monitoring and management capability built in, does that make them, not more reliable, but does that sort of assuage some of the concerns around fire or other sorts of risk? Because let's face it, most people with lead acid don't put in battery monitoring because it's too expensive. So
the chemist and the electrical engineer have been trying to get the lead acid battery to work for 120 years. We've now got, I go back to, I got an inquiry from Ford in Detroit for a load bank about early 2000s, maybe late 1990s. And the battery was 450 volts, 80 amps. And it was the first time they were looking at putting fuel cells into cars. I did a job for the I-Pace on the Formula E, because the Jaguar did. They had 20 cars running around the track before the Formula E. And they had to discharge the battery, because when they crashed on the first corner and they had to move to the next race, they had to discharge it down to 25% state of charge. And we designed a load bank which was 450 volts, 75 amps. So from that concept of the fuel cell to where the I-Pace is, and I stood back and I went, this is interesting. But I digress slightly. The electronic engineer and the software engineer are now working with the chemist and the electrical engineer. Yeah. So we know the problems of software. There is always an update, there is always a revision, there's always something that needs to be improved. With the electronics, you mean time between failure. If you've got a 15-year design life, what's the integrity on the electronics? Okay, what's the next version of the battery management system going to be? Where is that transparency? If you're changing batteries, if you have a failure of a block and it goes to fail safe, great, then you've got to replace that block. And the maintenance regime over the life, that 15-year life, are you going to wait to 15 years, or are you going to change it at 13 years? What's the supply chain like? In 15 years' time, hopefully I'm not doing load banks anymore, but, we'll see. It's a case of, it's another world. We've passed it on to the next generation. And if we do it correctly, then we can pass the knowledge on. We've got the longevity of this, but we've seen, the phosphate has come in because we've cut back on the capacity or the performance. I'll say performance. The metal hydride or the magnesium, whichever other technology burns at 150 degrees, is still being used in UPS. Yes. So you can mix and match this technology, and once you've sold the product and the data center owner has got a change of maintenance regime, change of owner, and other people come in, where is that transparency? Where is the path through?
Yeah, and I think you make a good point about the software, particularly about the longevity of software and the management of the software, which is required in lithium-ion batteries.
It's a risk.
Yeah.
There is a risk in that.
And how do Huawei deal with that, Richard? That sort of software element, because it's not just a physical presence, is it? There is a management requirement as well.
Yeah, as I mentioned before, there are lots of new things is coming around this kind of lithium, but the management and how you manage the software and how you manage the batteries, we have in every modules we have every cell sensors, and there's a very strict heart of this equipment. You can see it here. So this is basically controlling all the temperatures. So we are not waiting for the timer run away. We have lots of thresholds, and even it can switch off automatically. So you can change the modules, or you have all the different type of things. And I think when running a data center, the security means that you have an alert when it's necessary immediately for the right person to act and react. And secondly, it's not against the acid or not, but the management system is very important. And also in case of there is a operation and maintenance needed, or you have an SLA contract or whatever, the most important for the company to able to understand how to do the maintenance quickly and smoothly and fully transparent with all of the colleagues, because there was, in the last 10 years there was lots of accident in different type of batteries, and it was mainly because of the fail of the operation and maintenance processes. And we have also very strict processes how we do it, but compared to the acid, it's relatively easy to fulfill this kind of requirement. Is for the UPSs and also for the batteries.
Yeah, thank you. I think that kind of leads into another element of the operational management. And one question I'm going to ask is around the deployment and commissioning. I mean, is there a significant difference between the deployment and the commissioning of lead acid versus lithium-ion? I mean, how does that work, Phil? I mean, you supply both products, don't you? So I just wanted to...
I think there's a couple of issues really. I think the fact is that the lithium battery gives you far more visibility into the battery, the power source, the energy source, than you will ever have with lead acid. I know a lot of people have tried to put monitoring on lead acid batteries and put trackers on them and make them smart batteries, but at the end of the day they are eventually just a black box which you hope, if you maintain it, will do the standby that you expect. The commissioning and the installation of whether it be lithium or lead acid would be very similar. There is no real striking difference. What you will have from the lithium is far more visibility. And we have to remember that it's a different beast. It's not a lead acid battery. A lithium battery, if you monitor a bank of lithium batteries on float, it'll actually look like a sawtooth waveform. It doesn't look, depending on the technology you have, because the batteries will take the energy they need and then they will switch off, or not switch off, because that you feel as though they won't be there when there's an emergency. They basically back off and don't take any more energy. So you get a lot of insight into what's happening with the lithium, as Richard's saying. You can see there's a lot of thresholds. So from a commissioning point of view, I guess traditionally we still put in lead acid and then we test them, do a load bank test, whereas the BMS will tell you exactly the capacity, how much is charged, without doing all those tests. So there is benefits and features in both. Yeah. But again, I think there is a perception that lithium is very, very... It's not... the one thing that we haven't looked at is the recyclability.
I was going to come onto that. I'm
I
not
guess
ignoring it.
That's sorry to get to that point. You know, we can't suggest that lithium is the green solution. There are benefits: better power density, better cyclic performance, the fact you could discharge it to 100% depth of discharge. All of those benefits give you more in the data center. But a lead acid battery is 80-90% recyclable, and at the end of life still has some value. And that's what we have to address, is what are we going to do with the lithium down the line?
I think I'm going to go on to it, but I think we need Mr. Musk to start looking at it a bit more, don't we? So, Paul, you're very much on the commissioning side, and this is your sort of realm. I mean, is there any difference from your perspective in terms of deployment and commissioning of the lead acid versus lithium-ion?
The UPS is designed for a runtime.
Right.
So you're going to we don't do a DC test on the battery of a UPS in lead acid terms. It's the performance and the output of the UPS is what we're looking for. I hesitated there because in telecoms we are doing constant power testing, and we're doing some very short times on 380 volt DC systems. But if we pull it into the UPS in a data center, we've got to look at what sort of UPS we are installing.
Right.
Are we looking at one at the rack level? Yep. Are we looking one in the UPS room and the battery room? Are we putting the UPS in at all? Are we fitting out and then leaving it? Because we've got load banks which we use for the IST commissioning, and the UPSs do get a test as a consequence of that, but it's not part of level 5 testing. It's more the level 4 or level 3 testing, right, to prove the actual UPS in its isolation. I don't know. There's areas of this which go beyond, and I was going to think about the fact that you've got to, say you do an IST 5, and you've run the data center up from 10% up to 100 and back down to 10 to prove the air conditioning system and the power is there. That's the only time you're going to run a data center at 100%. So then when you come back to designing the UPS and putting it into rows, what have you got in that cold aisle containment that needs the UPS? Are you just doing your servers, or are you doing your network switches? Are you putting in, if your data center is going to run at 30% or up to 40 or 50%, if you're lucky, as you grow over that 4 or 5 year period, you don't need to put as much UPS in at the beginning.
Of course. Yeah.
And if you but if you went on thin plate pure lead, you've got 2 years where you can sit the batteries in there and not really use them. They can sit without being on charge. So where is the design concept? Where's the operation going to take over? Is it being considered at the design? Is it a problem for operations? They're a complicated beast.
And I think to Phil's point, it's not one size fits all, is it?
No.
So, Richard, on that point, I mean, where do you guys sort of fit into that design process, and what's your advice in this area? You've obviously got a very modular solution, so I guess that's part of the answer.
So first of all, I want to go back once for the services and commissioning. So because for us it's very important. So when you see commissioning, is relatively easy for our side. We have a rack, and we put the modules, and the modules what you need, and relatively easy to do the connection and all the other stuff. I don't want to go too much details now. But the other point, which is I think very important, that during the operation and maintenance process is also easier than a normal acid battery. But on other hand, lots of data centers are running at the moment the acid solution. Even there are some countries or some cities who doesn't want to use or doesn't want to allow to use any lithium solution, XYZ reason. Or as I mentioned in the beginning, so our approach is not only the battery, but the UPS is from the very beginning, from the data center part, is modular, let's say pay as you grow type of solution. And if we go a little bit deeper to the technology of the batteries, we can use different type of batteries, new one, old one, etc. We can mix it, and also in case of some failure, because of the BMS system can manage it very well, then we are using the whole system out of these 1 or 2 modules, and after we can change it. And all of the others, and as in the UPS, is basically hot swappable. So this is relatively easy to do the operation maintenance and teach the guys for it on field.
Yeah, thanks, Richard. I think, you know, the one topic we probably haven't covered yet is the one that you raised, Phil. You know, I think we're all aware of environmental risk in a number of different areas, and lithium-ion, I think, has, you know, some challenges potentially in that area. Where are the problems, and you know, what, if anything, is being done about it? And you know, I guess I'm going to ask each one of you for a perspective on this. But it seems like we're potentially building up a problem.
Yes, there's no real answer other than yes on that front. It was, from my experience, I actually had to get some batteries that have been damaged recycled, and I say recycled. Because I asked the company that was going to do it for me, I said, well, what is the process? And the process at the moment is that they store it. So we're not recycling it, we're storing it up for somebody else. You know, and that's not the greatest thing to do. And at the moment, I'm not aware of that many recyclable, you know, we can recycle parts of the battery, but it has to be something that we develop.
Yeah.
And again, but we have to balance that with the benefits that he gives us and everything else, but we have to be mindful that there is a problem that's coming. A lot of the vehicle batteries are now being second use, and they're being for home storage. So they are looking into that and trying to get a second life out of the battery, and that's great. But even then, that battery is going to come to the end of life, and we're going to need to do something about it, and we can't put it in landfill.
Right.
So we have to come up with a solution. And
I guess
but I don't.
Yeah, I guess as the problem grows, the solution will become more and more required, and we'll deal with it. But at the moment, there seems to be.
And also, lithium is a finite resource, so it'll become a point where there'll be a cost the initiative to get the product back out.
Because it'll have a value.
Yeah.
Paul, from your perspective, I know you got a view on this as well.
I did some research a few years ago. I was going to do a speech on an EV conference, and I thought, I wonder how many mobile phones were manufactured. I think it was 2017, 2018, and there was 1.5 billion phones that came out of the factory in a year. And I thought, that's a lot of lithium. Not, in relative terms, it won't be as much as 30 million cars. But it's still, and where did it go? Well, I've got a drawer at home full of mobile phones, so it's not gone to the landfill from me. But, there is metals to be recycled, and there's technology which can do that, but it's not doing it. We're not putting it through. There's not enough recycling plants at the moment to cover, say, mobile phones. When the EV cars come along, that's going to need a big development, and what we're talking about with UPSs in data centres will not be that significant. So we'll be on the coattail of other sectors that will drive that. Now, the battery course I went on a couple of weeks ago in the UK at NIBS, there was comments mentioned that lithium is not a recyclable product. Lead acid is 8%. So the lead that comes off the church roof or from your father's your father's motorbike will end up in your car or end up in a VRLA battery, maybe. But it just this product, that commodity is still used. So it's we don't really know yet, and it's not this industry that's going to drive it. We'll be on, as I said, the coattails of the EV.
And you make a point. I mean, obviously, we haven't had lithium batteries in EVs for long enough for them to be really sort of totally end of life, apart from probably accidents.
I read
again,
some information which said if we've got 300 years of lithium on the planet, right, and I don't know if that includes Afghanistan reserves or the ones in the Black Forest. You can't pull a leaf off the tree of a Black Forest, but there is an asteroid due to hit between Austria and Germany. So if you've got to carry a bag, you might be able to collect it as it comes up down from the sky. But this is 300 years before we go to these mega battery facilities that are going to be used for EV. And if it becomes 2050 we run out, or 2070, or 2080, it's not a long time. And we've used all that resource up very quickly. Can it be recycled? Will it be recycled? Is that something that, it sits under hydrogen on the periodic table, on the left-hand side, which is unstable, and lead's at the bottom on the right-hand side. There's some clues there. I'm not a chemist, but there's something in there which is like, there's been problems with it. Graphene might be a solution to make this more sustainable, but then you've got to manufacture. You've got to take 10 years before graphene becomes big scale. So there's things that are happening. Yeah. What sorts of generation are we looking at, in terms of the phosphate? There's another technology you mentioned, was the Titan. When does that then become an affordable version, and the benefits, and it comes down to be used? Yeah. So will it be before the 15-year end of life that we've got installed now?
Who knows? But I mean, Richard, maybe you can help answer that. I mean, what are Huawei doing about this, and how are you addressing the potential environmental impact and the recycling side?
Yes, thank you, Mark. So this is one of the topic I think which is very important. So I absolutely agree what you said. So there is an issue because it's not as easy as in acid battery. We have, of course, country by country third-party companies who can do it for us. But one of which I think is very good in Huawei is the innovation. So we are working together in universities in Italy and in Germany in this practical topic. Unfortunately, my colleague who ran it is not here today. I think he went home. This topic is one of the fundamental for the future. It's not only for data center lithium battery. It's a lithium battery as such. And when you see the different type of lithium battery and the raw material and how you can do let's say the recycling, I think we have lots to do here. I'm absolutely sure. And as you mentioned, most of the companies are doing storaging basically. And as in the first, I mentioned that we are starting working with lithium around 10 years ago. So we basically have a technology how to do it, but for this kind of modules, what we start to use for data center 4 or 5 years ago, we also start to work with third parties. And the rules and regulation is country by country different. So, and that's why it's, we can investigate a lot in the future, that's for sure. But again, there are lots of advantage, as we discussed today, and relatively low disadvantage rate, but one of them for sure, this kind of recycling ability and the management of whole life cycle process.
So it's something that's very much on the radar, obviously.
Exactly, but as the colleagues mentioned, so the acid battery, we have long-term history, 100 years or 50 years, whatever. In lithium, we have 10 or 5, some companies. But if you see more and more suppliers start to use different type of lithiums, so it will come to the market for sure. And I think in the medium and small data center, it will be in the top future. And when we're talking about retrofit, if they want to have more and more white space or they want to change the technology, there's always an issue with the space. And then lithium can help.
Good. Well, we're nearly out of time. I think we've maybe got a couple of minutes. Are there any questions from the audience? Anything any of you want to ask the panel whilst we've got them here and tightened the chairs? No? No questions? No challenges? Oh, here we go. One at the back.
There is a mic.
Oh, okay. Yeah, sure. I hadn't thought of that. Sorry.
How's it going? Just a quick one, right? You've both made kind of points for and against lithium and lead, and especially with the data center industry going forward, like the big players, you're still seeing them going with lithium above without regards to maybe carbon neutral footprint they're more dependent on the redundancy and the reliability that they have. Like, what do you see as being not necessarily the better option, but what would be more likely going forward for these companies to go for? Are they still going to go, well, lithium seems safer in the long run, or are we going to go with lead acid and just keep replacing them every couple of years, you know?
Are we doing a show of hands
Yeah,
in favour? The management of the risk is a consideration. Data centres are mission critical facilities. The implications of insurance needs to be looked at. The truth needs to be put on the table. Misinformation, sales, promotion, vested interests. Where does the industry, I wouldn't say regulate, it's not the right word, but the trade bodies, have they got an option to influence this, to put the guidance out there as things develop and new technologies, because the phosphate won't be the end solution. There'll be another one after that, and there'll be another software system, there'll be another electronic system. You know, this will evolve, and we've got to be able to visualize the evolution. On lead acid, the evolution has gone back to the pure lead and the thin plate pure lead. So it's not a significant change, but it's that's the most you're going to get out of the lead acid.
Absolutely agree. So I think when we're talking about a data center, it's a mission critical environment. And when I mentioned in the first minutes that security, I'm talking about not only the physical security, but security to run data center 7/24. And then that's why we need UPSs, that's why we need batteries, because there is no way to have any downtime or blackout or whatever it is. So that's why I think it's very important. And as I mentioned before, it's a different type of size-wise or module-wise data center. The as we see in Huawei, that and innovation guys said that the lithium is for the future for sure, but of course the technology going to change. And we are inventing a lot for new technologies about lithium-ion and the surrounding area also. So maybe titanium is coming, but I think at the moment is only in the spaceship using this kind of thing. So let's see what is valuable and good for the TCO also, and good for the environment also, because this is very important.
Agreed. Phil, final word?
Well, I think from any customer's point of view, they need to just evaluate the options and what each product gives them as a benefit. We have to be mindful, yes, there will be development. In fact, I'm being coaxed to go to Windows 11, so software is always changing, we always know that. So, but things will develop, and I think the benefits and features of either product will have to be reviewed by your customer or your client, whatever, and just go for the best fit that suits them, whether they need more space, higher capacity and smaller footprint, whatever. There isn't a one box fix all. That's the thing you've got to remember.
I'm just as a final word, I'd agree with that. I think it's sort of running a data center is all about risk management and risk mitigation. The reason we build a data center is to minimize risk and provide service availability. All I would suggest is that look at the true risks and try and ignore the perceived risks that may or may not be correct. And so understand the true risks, and therefore in each individual situation and each individual use case, come up with the right solution for your particular requirement. That's it. And that is, I'm afraid, all we've got time for. We've actually run slightly over. So thanks to the panel. Thanks, everybody, for your contribution. And thanks, everybody out there, for listening. Thank you.
Thanks.